I suppose I'm audible.
Yes, good morning.
All right, so we continue to, let's proceed. I hope yesterday I had to leave abruptly. So we are looking at the possible health effects from RF EMF waves. And we were talking about specific absorption rate. So we wanted to look at some practical scenarios on the aspect that affect that SAR level. So we say that you could consider a lot of things. SAR depends on the power that is transmitted from an antenna, which is producing those waves, RF waves, and also the distance from that antenna. It will also be affected by the type of antenna, the radiation pattern, or the multiplicity of those antennas. If you have several antennas, that will also lead to different radiation intensities. Apart from the source, you could also be considering the technology. Now, technology would also consider the number of antennas that are in a device, or the frequency, not just bandwidth, but the carrier frequency that you're working with, because that then affects how the waves are absorbed. Apart from that, also, we say that whoever is being affected would be an adult or an infant, male or female. So we have to consider all those, and then the age of that infant. So we have to consider all those factors. Also, in the human being or whichever animal we are considering, we have to look at also the parameters of the medium or the tissue. And here the tissues can be the skin, the fat layer, meat layer, bone layer, or the brain itself, or any other organ that you are thinking about. So you may want to see how they're affected by this RF EMF. So there are different permittivities and permeabilities for different tissues. So you can consider that when you're analyzing the effects as SAR levels. So here we had started with the microwave technology. So we chose microwave and we said next. This is for any lay person who is able to see some of these devices where they are. So it could be occupational or just the public. Normally ITU and CAK would give regulations. I'll check if I can get one about a template to be filled by network service providers or people. So long as you have some RF devices in your company, you are expected to report under environmental assessment, impact assessment every year that these are the kind of SAR or electric field or magnetic field intensity that your people are experiencing. So it is important that even if non-engineers should be able to see this effect. So here we have a microwave. So in this case, we just didn't mean a microwave, range. Here we meant the 2.4 and 5 gigahertz. So if you choose any other thing, like a Bluetooth dongle, let's say Bluetooth works on the same. Let's say you select a phone, okay, and you try to go next. Then you'll have that exception where it'll tell you that does not match a microwave technology. So you're supposed to make a new selection for the RF device, okay? Because, somebody else who is not an engineer may not be able to select, so we think that things have stopped at this point. So what you can choose here is a microwave oven, which people see at home, and their main concern is always whether it affects an infant or not. So the infant could be gender, could be male or female. I think we were there. You can choose the age. Let's say that 36 months that we're seeing there. And then the head size will come automatically because those are from the databases. You can choose how far is the baby from. the oven, and you want to see the effect on the skin. So then we can calculate and see that the SAR is almost near the limit of 2 watts per kilogram of tissue of the skin. So you can see that's if they say that it is dangerous. So for us, we are not looking at the health effects and saying, qualifying that this is what happened to you when this kind of radiation reaches your skin. That research is still ongoing, but we are limited to this standard. So long as we are able to show that the radiation in the environment is within the 2 watt per kilogram, then I think our work is done. Any other argument beyond that requires some research. But we'll see with the presentation that we had before, just to see some of the research that have been carried out that show that actually these radiation levels could be dangerous. And you can see how the power reduces drastically. That was from 9 centimeters away from the microwave oven. What if you were like 10? So we saw that was 1.956. So 10 centimeters away, you can see it moves quickly down, degrades by the, this follows the inverse square law for the distance. 11, 0.9. Okay. So you can actually plot that those SAR levels over some distance. Then you have, you can do, so we saw 9 was okay. What about 8? Just near 9, 8.5. 8.5 is 2.3. Then 8, 2.9. You can see how drastic it goes. What about 7 centimeters? Because here we are assuming that when the radiation that comes out of the antenna is isotropic, so we're just assuming it's going all around. But microwave oven, definitely, if you go with a coustimeter next to it, you realize that the levels are really, really high. Very, very high. Because the microwave oven is a cage, so it's controlled. So radiation happens within in a directed way. So 7 would be 4.6. That's 6. These are now dangerous levels according to ITU and ICP. Those are the ones that give us, I think it's a European standard for non-ionizing radiation. Something else we can check, let's just go to near the point where it is almost dangerous, at 9 centimeters away. So that's the skin. It's 1.96. So if you can note that down on the skin, the fat, depending on the permeability and permeability in the fat layer, it would go down. And of course, it's further. The fat layer is further from the antenna, which is outside the skin. Then you see that 0.01. The bone would actually be higher, even though it is further away because of the properties, electrical properties of the bone compared to the fat layer. The brain, the electrical properties are even higher electrical because there's conduction there. So we want to see how much you get in the brain. You can see 0.39 because of the electrical properties of the brain, which is higher permittivity. So that's how it is. So what distance then would make the brain go beyond 2? So we can do 5 and see. Yeah, so it's about, if you move like 5.5 centimeters away from the open, you can see almost in a dangerous zone. So 5.4, 1.79, 5.2. It's 2, almost 2 watts per kg. So that's how dangerous it is. Because, and yet remember, 63%, the skin depth covers 63% of the skin layer. So most of the signals will be flowing within that skin depth on the skin layer. So what we are talking about is just the power that goes beyond that skin layer, through the fat layer, through the bone, then to that which is the skull, then to the brain. So you'd imagine if the brain was not covered by all these layers, and look at how much it would be affected. So we're just hoping that the international standards are giving us good standards such that we know if we are below 2, then we are not in dangerous environments. We just trust that is it. So that is for microwave. For others, you can choose a technology and choose a 4G. 5G, it's arguable whether there is 5G or not. There's no implementation that has ever met the standard of 5G yet. Yet they called it 5G for marketing purposes. So 4G, we want to talk about your 4G phone. You are not an infant. Let's now choose male. Head size. How far do you put your phone on your ear? You even make it touch, isn't it? So it's 0 distance. Then, so it means the only distance we'll have is about the skin depth only. So 0 does not really cause an issue. You want to see the effect on your brain? So we calculate is very little on an adult male. Okay. What about the bone? But this also depends on the frequencies. Skin. Okay, I should be running them. That's the bone, then fat, you see. 003. Skin 006. Yeah, so they're not dangerous at all, just from your phone there. Okay, so that also depends on the power class, which we'll see that 4G power class is not mentioned here. Let's look at the parameters if at all we can write the details of the power class. We didn't show the power class here, so it's 4G phone skin impedance skin there. Let's see, yeah. So the power class is not given, but we must use a certain power class so that we know how much is your phone radiating according to standards that are used by the network operators. So that is that. Any question here? Because I want to move to a presentation that we did, which may highlight some of the parameters that we use and also some of the diseases that have been researched upon. Were you guys able, is there anyone who was able to test the calculator online? Okay. So silence, I don't know. Am I reading in class? Let me see. Are you guys able to hear me?
Yes, I was able to access it.
Yeah.
The website, but I think it was not under the domain of UN, so I couldn't quite access the website via UN Wi-Fi.
Oh, is it? They don't allow you to go outside?
Yes, it was blocked.
Ah, okay.
Or maybe I tried a wrong URL.
Are you seeing the one here now? Because the URL is just EMF Health. Even if you search it online, you should get it. EMF Health. UN PowerNet. They actually the website is UN PowerNet, but it's not for the UN. This is my website. Oh, so Alphonse, you're saying you can access it now? Yes, Ismail Lennox.
Yeah, I have a question about a statement that you said that there is currently no implementation of 5G networks and it's purely for marketing purposes. Can you please expound more on that?
Yeah, 5G standards have not been achieved by anyone. So normally, well, what they have achieved is just to move the spectrum of 4G from the 4G bandwidth to a new bandwidth between 3 and you can go up to as much as 300 gigahertz if you want. But the main standard for 5G is that they were supposed to achieve a latency of 1 millisecond. So that has not been achieved. So you can't say you have achieved 5G if you have not achieved the standards that are set. So that's the main thing. So people are still struggling to do it. So for me, even yesterday we were discussing actually a lot about 5G and 6G and things that people are supposed to be implementing. So we argued that what we are talking about is actually just 4G, which is implemented on a wider bandwidth. So it's just on a wider bandwidth. 5G was supposed to really achieve, key milestones in virtual reality. I mean, implementations that require that within a millisecond you've made your decision. So yesterday when we checked and we say, okay, now present to us any application where you can do below 20 milliseconds. Now nobody showed. Yeah. So it's more of, for me, if you are really highly technical, then you understand that it is really just marketing. They will just call it extended 4G, the technical guys who know what is being done. But on the other side of the users, definitely, everyone will be running to buy 4G, 5G phones. And that's why you are seeing people are now talking about 6G. How come? When even the 5G has not been run? Because if 5G were to be achieved, then people would stick to that 5G for some time. But they realize that, it's not easy to achieve that latency. So the people are adding more work to be done on top of that 5G standard. But you see, because you already said, so you have to say another standard as researchers still work. Yeah. I'll be presenting next week, I think, through IK on 5G. I don't know how you guys will be invited, so you can be there for more description on what 5G is and what has been achieved and what has not been achieved, and probably comparison to what do we want to achieve with 6G. All right, then we go to let's have a quick scan over this webinar that we held. So if you're able to see it, there was concern that time that the COVID-19 was manufactured in a lab, a 5G lab. So it was important that we look at our environment and see if 5G were to be used in the environment here in Kenya, what would really happen? Yeah, so that's Kenneth. They normally have some proposals for funding every year, so you can apply and compete and get it. So I think we got that. So we rolled out some, experimental campaign with some devices that you just walk around with the acoustimeters and then pick up the values of electric field intensity. So long as you have electric field intensity, you can relate it to the magnetic field intensity through the intrinsic impedance. So it means you can calculate your power through Poynting's vector, power density, and then from there you can get the SAR levels. So the students did a good job. So this presentation was the, I think, 2020. So what is here is more of, actually it's on the website. You just need to go to webinars. Yeah. Go to webinars, you should get it. You go to webinar 1 there. So you can actually just have it there online if you don't download it. So here we have, we look at the RF sources, the radiation safety code, the spectrum. Then this was key that time, oxygen absorption of RF. The main issue here was that at 60 gigahertz, that wavelength at 60 gigahertz somehow really resonates with the oxygen molecule. So it could be that they are of the same sizes. So it causes the oxygen to spin a lot because of resonance. And due to that, all the energy that is coming from the wave will not really go through oxygen. So there's a high absorption rate of 60 gigahertz by oxygen molecules. And you remember during the test for 5G, 60 gigahertz band is actually a free band. So it is the one that was recommended for people to use for 5G tests. So that's why people thought that this COVID must be related to 5G that was being tested in Wuhan. So the conversations were around that. Others thought it was conspiracy from animals, things like that. But with oxygen absorption at that high rate, and it's the same oxygen that you're breathing, there's no really conclusion whether the DNAs were not changed to RNAs. Nobody has concluded on that. So still, research can still go on to check, because what we normally look at is what is the effect of energy in raising the temperature. And that's what we talk about SAR. Is the rise in temperature, is the heating effect. But people are not doing research in the spinning effect. So spinning also consumes energy and it causes movement, which is mechanical. So how does that then? That mechanical movement will also lead to some heat, but the spinning itself would also cause other, chemical effects on other cells. So that's not well researched. Then we look at the measurement equipment, the bioeffects, and the remedies that can be taken. Then the students presented, I think, on the 2G to 5G, different parameters that you can consider when you want to compute the SAR. And also from the radio towers, these are on different frequency bands, about 40, 400, 500 megahertz, right? And then, of course, now they showed presentation on the website. So what we have here is the measurement campaigns were in several cities. This time around, students would go home and then go with those meters and do their measurements there. Some would be sent on highways and then do their measurements, and train station and all that, and the CBD and the estates. So some of the sources, you can talk about communication antennas from base stations, TV, radio, radar, oven, meters, access points, IoT, okay? And they start as 2G to 5G devices. You could also talk about natural sources on Earth, infrared, RF, sky lightning, and the sun and outer space. So there's radiation activity, where you just measure the effect of that radiation, and then exposure, where you measure what is the effect after you're exposed for some time. So for example, we were saying you are near the microwave oven, you are beyond the limit, and then you move away. That is just radiation activity. But now what happens when you are exposed? Like you stay there for 10 minutes, what happens to you? Probably if it is beyond 2 watts per kg, then probably you would be burnt. So there would be some cells that are damaged. Then the radiation by effects. Now this, depending on what kind of study you are doing, you could do epidemiology, where you trace some of your studied subjects over time and see the difference. Or you could expose rodents to a cage and then inject radiation there through an antenna and see the behavior of those animals. Or you could actually inject expose some of those tissues within test tubes and measure. So these are some of those devices that you use that you would be concerned about. And the spectrum we're talking about is non-ionizing, so it's actually just at the visible light going backwards. Beyond that, in the ultraviolet going forward is ionizing radiation, or X-rays, gamma rays. You know how small these ones are. Actually, they are particles, so those are highly dangerous. So the exposure should be very limited time. But there are specific wavelengths that are also used to break down certain chemicals in cells. So again, you just need to know what levels are required, like for phototherapy. Then, so we are talking about non-ionizing radiation. We are not talking about ionizing radiation. So that's where our concern is. So you can see the RF from down there. Let's say from power lines, I don't think those are very huge wavelengths that will not affect us, 50 hertz to 60 gigahertz. So we can talk about, we start from a kilohertz all the way to 30 gig. Okay. So that's our concern. So you have smart meters 0 to 2.5, Wi-Fi 2.4, 2.5, or 5.8 gigs. Your remote control is on a 5.8, mobile phone 1.9, 2.2, radio, AM, FM, TV broadcast. So all this. But remember, when you are in the environment and you are not, if you don't have a tuner on your meter, so you are going to actually have the cumulative effect of these waves on your meter. So it will not just be one frequency. So the meters that we are using could actually be able to measure the electric field intensity over a range of frequencies. So they are integrated. So this is the characteristic attenuation against frequency in dB per kilometer. Okay. So if you inject a wave under these conditions of water vapor and oxygen, you can see at 60 gigahertz, almost at sea level or at 9150 meters altitude, at sea level, you can see absorption is very high of those waves, about almost 20 at 60 gigahertz, 20 dB per kilometer. Every kilometer you lose about 20 dB. So that is high. That 20 dB is 10 raised to 2. So if it is in watts, 100 watts, that's a lot of power. If you are to transmit your signal for like 2 kilometers, you do not reach at all. Okay. So you can see that's what we are talking about. So it means at 60 gigahertz where we are testing the 5G, the oxygen spin is a lot. Absorbs all the energy. That's what it means, and this graph means that the energy will all be absorbed. That power will all be absorbed within the oxygen molecules. So as we use these extended frequencies for 5G, we need to be careful what is it that we are really doing to the environment. So this graph is very important. And that peak of 60 gigahertz, that's why this ITU decided to make it a free band, ISM band. And you can also see water vapor, oxygen also at 100 and something, maybe 120 gig. Also, there's a peak there. So those are areas you want to avoid too. Those are bands that you don't want to use, because you can see the effect that it's going to have on oxygen. And if that oxygen still remains in the air, I have not done research in that area, so I'm not sure what happens. And you breathe oxygen, which is energized, what does it do to your cells? Okay, so that's a question for others to do. So that is the main thing there. So the safety codes, you get them from the International Commission for Non-Ionizing Radiation and Protection. I think it's from Europe, and the World Health Organization. So the levels that they give to be dangerous are 2 watts per kg. So starting from 56, depending on what frequencies you want to use, if your measurement device gives you a 56 volts per meter in the environment, then you should be sure that you're in a dangerous zone. The things that the safety codes don't consider: short-term thermal effects, long-term exposure studies are not there. Then also there's lack of sufficient studies on non-thermal effects such as frequency healing, where you just listen to frequency and it heals you. So what that means is that there are no or very limited studies on resonance of frequencies with these molecules. Just the same thing we have seen with oxygen there. So these are the meters you can use. 10 Mars is one of the brands, and AM11 is another one. This one you can see the AM11 has 200 megahertz to 8 gig. So that can measure up to 5G lower band, FR1. Then the other one is up to 3G gigahertz, 10 miles. And we have several of them in lab. You can borrow and go measure things at your place, and then you return TM195. So the study type is for exposure is epidemiology, so association. So you have a case and then you have a control in a population. So you have people who have this condition and the people who don't have, then you study them over time. Or in vivo, so cause and effect. So you can subject these rodents in a cage and study them and inject them with an antenna, you transmitting signals within that cage and see how do they behave, and you can control it also, or you can just monitor their behavior over time. Or you can subject cells into test tubes and see what changes occur. So those are some of the ways in which you can do your studies, but you need medical practitioners as well in your study group. We didn't get there. We just work until whatever we have in our environment, does it go beyond the engineering limit or not? So we need to consider adults, infants, and then technology 2 to 5G, and any IoT device. So from literature, we see from epidemiological studies, blood cells with genetic damage were registered from engineers who are working closely, the military men who are closely working with radar systems. Memory loss and attention within 300 meters of BTS. That was also noted under some studies. Yes, Mark Murigi, you want to ask something? Or you raise your hand without knowing? Then we have dizziness, headache, and decrease in libido would also happen. Then the sperm count for the military radar personnel. And we can see the kind of the power that was within the room where these military personnel were. It's 10 microwatts per meter squared. So they did studies and realized that actually the sperm count also goes down for those engineers in military. Then in vivo studies, there were records of tumors, infertility, stress reaction, altered brain waves, permeable blood-brain barrier. That's a very dangerous condition. If you make that blood-brain barrier permeable, it means then chemicals would leak into the brain. So we can see that if when those rats are subjected into those cages, then these conditions occur, and also the reduction in the production of testosterone. So indeed, some of these things already highlight that how dangerous these waves are. In vitro, we say this. Now you look at you subject then the cells themselves into test tubes. So here the cell division tumors were recorded, genetic changes, stress proteins, and immune system malfunction. Right, so we are not very authoritative in reporting this, but these are papers that have been presented and published online. There's a way we can present them, but for now, just take note about some of the effects, medical health effects that actually occur. So we just need to identify jobs with increased RF exposure, lessen the exposure near RF base stations, also the phone near body parts, and use protective gear when you're exposed due to your occupation. Okay, so we can look at a few of the work that were done by these students. So we had that team of Harriet, then Alvin and Alan. So you can see Here we had talked about this. The SAR is that formula where you have the sigma conductivity times the electric field intensity, which is squared, and then over 2 because of the RMS value of that tissue density, which is kilograms per meter cube. Yes, written kilogram is equal to meter cube. So SAR, so electric field intensity is basically the power intensity you divide by the resistance, right? So power is V squared over R. So it means you can actually get E squared as power times R. So that's why you see the intrinsic impedance here times the power intensity will give you that E squared. So with that, but D, we know that D there in the denominator here is the distance from the source of RF to the tissue. But within that tissue, we are also considering the skin depth within the tissue. So D will be some delta, which is the skin depth plus the distance in the air from the RF source. So even if you put the phone on your skin, the D in the air will be 0, but the skin depth will still exist. So power skin depth is D delta over 2 is the depth within which 60% of power is dissipated. So that you should just take note of that, because in literature you may realize some people use this power skin depth rather than just the skin depth. So we have said that we can express E in terms of power by multiplying by the resistance, which is the intrinsic impedance in this case, eta naught into root of mu R over mu epsilon R. Then this is the power GTPT. You are transmitting at PT, but the antenna has again GT. Then you divide by the isotropically, the waves are going all around. So it's 4 pi times the radius squared. In this case, D will be dA plus delta. So you can expand that out, because even delta, you know what it is, because we want to see the factors that we know. So you would see that we have 4 pi into dA, but the delta is root of 1 over pi f mu sigma. So you can expand that SAR equation so that you are able to appreciate the parameters that affect SAR. And this now allows you to do the calculations we were doing based on these parameters that we know. For each tissue, there's a different, we know there's a different frequency being emitted, but we have mu R and epsilon R for different tissues, and the tissue densities and the conductivity of that tissue. So you can see we are able now to and then GT would also tell you the different antennas have different gains. So if you are using a certain antenna, then that also tells you. PT, if you're using a power class for 3G, which is different from another power class in a 3G, again, that can be modified by that. If there are multiple antennas, that also modifies the GT. So we have all the factors that we need. The frequency, of course, is the center frequency that we're using. The skin depth is given. That's how energy is propagated. Okay, so the equation governing that propagation is E naught exponent minus alpha x. Alpha there is the attenuation constant, which is basically in air will be 1 over delta, because there's no conductivity. Since power is proportional to the square of the magnitude of E, power propagation can be given by that. Okay, so in terms of power, you can have, that's power propagation, so you'll have delta over 2. Okay, so that we have mentioned all this. Now, we want to look at the SAR for 2G or 3G. There are different power classes, so you can see power class 1, 2, 3, 4, 5. So if Safaricom implements from the BTS watch class, so you need to know whether it's class 2 or class 3. So the peak power for class 1 is 20. You can see for 4 is 2. So meaning if you're implementing in town and you just need a short range, you need to choose the power class. If you're in a rural, probably you will implement a class 1. Okay, then power per user, then 2G, that is 2G on 900, which can go further. Then 2G on GSM 1800 band, 1800 megahertz. You can see the class 1 is just 1 watt. Okay, but again, class 3 is 4. That class 4 is 20. So you must really know what you're implementing. Then 3G 2100 megahertz is class 1, 2, class 2, 0.5, like that. So power class is very important. It affects the intensities in the field. 2G power classes. Then we look at now the layer. Now the skin depth. So these are calculations for power class 1. So if you use a power class 1, then you can now do the calculation because you know the skin characteristics of for electrical properties and magnetic properties. So you can calculate all this. Power density, the impedance is given, then field intensity, and the SAR. You can see how high they are if you are just to be at the antenna. But these ones, this probably are at the BTS. So you need to be very far from it. Otherwise, it depends. You see the effect on the brain, you see the effect on the skin because of the electrical properties. And yet the bone and the fat, it will just pass through. Then 2G power class. This is class 2. Okay. Then now you can plot them. Class 1, class 2, class 3, class 4, all that. Okay. And then you show for skin fat. Skin and brain would definitely be up there. Then the fat bone will be below there. So those are doable easily. I think that's all. 3G, also power class 3, you can do the calculations. Then 3G power class 4. Then now radiation measurements on 3G. 2 centimeters away, we put your 3G phone 2 centimeters away from your ear. Look at the effects on these tissues, skin and brain. Okay, so power class 3 and power class 4. You can see how power class 3 affects that. It's beyond the limit, it's beyond 2. And the brain. Okay, so this is SR 3G 900 megahertz at 2 centimeters away, the same. But this will not be more than 2 watts per kg. You can see it's less than 0.8 because we are using that lower frequency, 900 megahertz. All right, so those are things you should be able to understand. Then they did radio transmission, technical studies on radio and telecom towers. KBC radio, Taifa, Nairobi region is on 92.9 FM. They're transmitting probably from Limuru or Ngong at 5 kilowatts. Namanga 89, Nakuru, all that. Okay, up to Kapenguri, Nyeri, Rift Valley. Okay. Then you can do telecom tower power profile. The transmitting tower is there at 50 kilowatts. Then now it depends on how far you are. So probably there are some certain, how far was this person? But see now in the air, when it reaches the skin, it goes down, fat down, bone down. Brain, for this case, also down up to that point, the center of the brain. Right, so you can do a profile from telecom for any study that you're doing. There is a 6-layer human head at frequency of 1002.7. These are theoretical for 3-year-old baby. You see, because you know that the characteristics of the tissue, so you can always do all these calculations. Even using the calculator we have on the website, you can now populate these tables. We also have here SAR for 6 layers of for 3-year-old baby with incident power of that at 102. So that's listening to radio. So the SAR 102 megahertz. I'm wondering the distance. It's not shown here what distance and how old the 3-year-old. 6 layers. That incident power on the skin probably. That could be the incident power on the skin. So you look at the effects. Then radio telecom towers. Anyway, from you can calculate whether it's 4G, LTE, or 5G technology. You know the frequencies that you want to look at. You can use that equation to calculate the possible SAR levels. If a 4G phone with 2 antennas, and the spacing among the antennas is known. You can also calculate. Now, this probably is an in-depth study. You can look at it later. How do you then get the antenna spacing to affect the power that is radiated out of it? Okay. Then we have 4G phone 2 centimeters away from your ear. You can do the calculations and plot the profile. 4G phone on the skin surface. 5G on the skin. Then you must also note how many, 2 centimeters away. Okay. All these calculations are possible. So just you should be able to access this even under university Wi-Fi. You just need to either click advance or something like that. Just say that you trust the website. You should be able to go through. Yeah, so that is it. I think this was a Machakos study, which are all in the website now. So this is what you get, how you get your data points. So you just press the machine and get your, as you walk. So this is from point 1 to point 200. And you can see this student was walking. This is RFE field strength in millivolts per meter. Machakos town on 21st May 2021 from Machakos to Kitui Road, Ministry of Labor area. There's Kariobangi Estate in Machakos. Anyone who knows? Then Sokoni and Syokimau Avenue, most likely. Londiani area. Londiani, we realized that, but the winding Londiani with the hills is causing a lot of problems. So you can see there are points on the ground there which were 20 volts per meter, even up to 25 volts per meter. And this was in the car. So it means if you step out to really do real measurements on those winding roads, you realize that due to the hilly nature of the area, the transmission antenna, the backhaul transmission antenna from one BTS to another BTS would actually have the Fresnel zone that is very near to the ground because there are hills in between. And that is what is causing these high electric field intensities within the area. So that must be a very dangerous area. And if you include now all the telcos having their sites there, then it's an area of interest that should be studied further. Okay, so that is it. Any question on this? Because next week now we start your presentations. I just wanted to take you to where you're headed. At the end of the day, these are some of the areas that matter to the society. So you need to understand the effect to the human or the environment. That's what will be asked. So maybe I'll share with you next time the template from CAK. My tablet is not able to connect to this Wi-Fi here. I would have probably, I'll share it. Safin, if you're in class, I'll share the template from CAK that gives how you report the environmental assessment on EMF, which is important for you to understand how this relates to the regulator and the society. For now, if there's no question, then you register your attendance on the chat. It's calling from Safaricom.